In this video, we're going to look at stepwise refinement. This is a common problem for new programmers when they're given an assignment, especially as a semester goes on. When we're learning to code, the problems get more complex, and sometimes students will look at a problem and say, I don't even know where to begin. And that can be kind of demoralizing sometimes. But there are ways to tackle those big problems. And the first part is don't look at everything as a big problem. Look at it as a whole bunch of little problems that have to be solved. So when we write a large program, we can use the divide and conquer strategy, which is called stepwise refinement. Or decomposition is actually the technical name that a lot of people use. We decompose it into smaller sub-problems. Then our sub-problems can be further decomposed into smaller, more manageable problems. And we just keep that idea of breaking big problems. And if we don't know how to solve them, we break it down into some smaller problems and break those problems down to even smaller problems until solving the problems, the little problems, become so trivial we don't even have to think about it too much. Okay, so we're going to go through and just talk about, in theory, a little example to see how you could break down this big problem that you may not even know how to start, so that you don't get overwhelmed when you see a big problem thrown out in front of you. So this is the print calendar case study. Let's use the print calendar example to demonstrate the stepwise refinement approach. So enter a full year. So this allows the user to enter the year 2009, and they can enter a month in number between 1 and 12. So this user is asking for 4, which is April of 2009, and we need to generate this calendar. I don't even know how to begin. How would we begin to do this? We could probably see some things. We're probably going to have a loop that counts some things, maybe. But first, we got to print that title up there. So let's not get overwhelmed by all the things that we have to do. Let's start breaking it down. We have to print a main calendar. That is our overall goal that we want to do, is print a calendar based on some user input. So right there, we have two problems. We have to be able to read the input from the user, and we have to be able to print out the month. So we've just broken this big problem down into two smaller problems. Okay? But what does that involve? Printing the month means we have to figure out the title, because they're entering a number 4, right? So we have to figure out how to print the month title. And we also have to figure out how to print the month body. Okay, seems logical. I'm not even sure how to begin breaking down printing the month body, but to print the title, I know I have to get the month name based on the number they entered, right? So there's something we can do. To do the month body, I probably need to figure out what the starting day is for the month, and I kind of need to know how many days are in the month. So I need to figure those out. And then I need to get the total number of days. That's related to this, get the total number of days in a month. Okay, so these are smaller problems that I might be able to figure those out. I also have to check to see if it's a leap year. That's something else. So I put this all in my diagram. I need to check to see if it's a leap year, because if it's February in a leap year, I have to print an extra day. And we break it down into all these things. Now, each one of these things can become a method. So let's take a look at a skeleton program. Here, I'm asking the user to enter the full year and enter the month between 1 and 12. And then I have gone for each one of these little subtasks that, this overall print calendar might have seemed overwhelming. But I broke it down into these small tasks, and each one of them can become their own method. And then we wrote some method stubs. Public void print month. Okay, and it's just system printing out the month and the year. We have a print the month title method, and it's empty. We have a print the month body method, and it's empty. We know we have to be able to get the month name. Somebody's going to put an integer for the month, and it's going to return January. That's just a dummy value right now. We'll have to write some logic in that method to take the month number and return the correct month name. I think that's a problem we can solve. Get the start day based on the year and the month. Is there a way we can calculate what day of the week that month starts on? But for now, we're just going to return 1. It's a dummy value, but we'll write the code for that method later on. So we write all these stubs, these method stubs. They don't really do anything. They kind of return, we determine what information needs to be returned, and we determined what information we need to know in order to accomplish the tasks, and we just return a dummy value for now, and we'll write the code for it later. But you can see for each one of these stubs, we had the related problems broken down up here, and we wrote a stub for each one of these. Okay, and now we just broke our big problem down into a whole bunch of small problems that we can probably tackle. And if we find out that one of these is still too hard, we can break it down further. And we keep doing that until we end up with a program. And here is the program. Get number of days in the month. There's some code. Most of us could probably write that. If it's 30 days has September, April, June, and November. So if it's a 4, 6, 9, or 11, we're going to return 30. Right? We do have to check if it's month 2, is it a leap year? And we have a method down here, is a leap year that we wrote. So all these little methods that we wrote are pretty small and they're pretty easy to do. Okay, we broke the big problem down into all these small problems and eventually wrote the code for each one of those little method stubs. And this is a working program. It started out as a bunch of method stubs, and we figured out each method as a small problem, and that allowed us to solve our big problem of printing a calendar. So there are different ways people prefer to do this. There's a top-down approach. That's implement one method in the structure chart at a time from the top to the bottom. We can use stubs for the methods that we're waiting to be implemented. You know, a stub is that simple but incomplete version of a method. The use of stubs enables us to test invoking the method from a caller. That's why each of these stubs had a return type and some parameters, when we had stubs here, and we returned dummy values, because then we can practice making those calls even though it's not returning correct values yet. Okay. We implement the main method first, then use a stub for the print month method. For example, let print month display the year and the month in the stub. We saw those examples as we were looking at the stub. Okay, and we looked at that skeleton. You can also do it from bottom up. Take each of those methods, start with the bottom with the simple ones, and implement one method in the structure chart at a time, working from the bottom up. As you write each method, you write a little program to test the method. Either way, both top-down and bottom-up methods are fine, whichever way you prefer to tackle it, and it might be different for different problems. Both approaches, whether we go from the top down or from the bottom up, implement the methods incrementally and help isolate programming errors. We're testing each one of those small methods one at a time to make sure they work correctly, and that makes our debugging easy. Sometimes you can actually use them together. You might write part of it from the top down and part of it from the bottom up. You might even assign, if you're on a team, each one of those methods can be thrown out to a different member and say, here, you solve this problem, and you solve that problem, and you solve that problem. And when we're done, we'll be able to take all these methods and bring them together in some place like a Git repository, and we'll have a fully working program.